Your computer boots. The desktop looks familiar. Then a thin line of text settles into the corner of the screen, quiet and absolute. This copy of Windows is not genuine. Features may go dark. A watermark stays put. Nothing crashed, nothing smoked, and yet the machine has withdrawn a kind of trust you never knew you were borrowing. Here is the stakes of that moment. Windows is not only software on a drive, it is a relationship between a license, a machine identity, and a set of internal records that prove the two still belong together. When that relationship breaks, the operating system does not always know whether you are a pirate or whether the proof simply went missing. So the question is not only how to make the watermark go away, it is sharper than that. Is this copy truly unauthorized, or has Windows lost the evidence that would prove otherwise? Tonight, we treat that warning the way a careful investigator would, not as a single fault, but as a short list of failures that look identical from the outside, and a ladder of fixes that starts with the official path and climbs into the places where Windows keeps its secrets. Before you touch a single setting, name the suspects. The source behind this investigation lists 4 common reasons the not genuine warning appears, and treating them as rivals is the whole method. Suspect 1, the trial expired. Many installations begin life on temporary authorization. When the clock runs out, Windows does not become a different product overnight. It simply stops granting the privileges of a verified license. The machine looks the same, the trust does not. Suspect 2, the product key is invalid or was entered incorrectly. A product key is an identity string. One wrong character, a key meant for another edition, or a key that has already been retired from service, and the activation service refuses the handshake. From the desktop, that refusal still looks like the same watermark. Suspect 3 is more physical. A major hardware change, especially a motherboard replacement, can rewrite the machine's fingerprint. Licensing systems often bind proof to a profile of the hardware. Swap the board that is the spine of the computer, and you may have, in the eyes of activation, built a new machine while keeping the old hard drive's soul. Suspect 4 is quieter and easier to miss. Activation files corrupted or missing. Here, the license may still be legitimate, the key may still be valid, but the internal records Windows uses as evidence have been damaged by incomplete updates, disk errors, aggressive cleaners, or simple entropy. The proof exists, or once existed, and the system can no longer read it cleanly. Notice the pattern. 4 different failures, one public symptom. That is why random fixes feel like superstition. If the hardware still looks like the same computer sitting on your desk, why would its identity fail? The answer depends on which of these 4 stories is true, and the first move is not a deep dive into the registry. It is the safest, most official route the system itself provides. Think of activation as Windows asking a simple question: can you prove who you are? The cleanest answer is to hand it a valid product key through the official activation workflow. The source calls this the safest and official way to fix the issue, and for good reason. You are not rewriting policy. You are not granting new permissions. You are restoring the identity the system was designed to check. Here is the flow, step by careful step. Press Windows and R together. That opens the Run dialog, a small doorway into named tools. Type the activation launcher exactly as written: slui.exe, then a space, then the number 3. That is slui.exe3. Press Enter. Windows opens the product-key entry screen. This is the moment of identity. Type a genuine key that matches your edition. Follow the on-screen instructions through to completion. If the key is accepted, the trust relationship is reestablished the way Microsoft intended. License meets machine. Records update. Watermark should release its grip. Real-world scale helps. A product key is not a password you invent. It is more like a deed to a house, a unique claim that a particular installation is authorized. Handing over a forged deed does nothing. Handing over the right one ends the argument. But hold the tension. What if the key is valid? You know it is valid. and the warning still returns, then the problem may not be the identity you offered. It may be the filing cabinet behind the desk, the activation records themselves, damaged enough that Windows cannot complete the proof even when the answer is sitting in your hand. That is where the investigation escalates from identity to evidence. Imagine a library that still owns the right book, but the catalog card is torn, the shelf label is wrong, and the barcode will not scan. The book is genuine, the proof path is broken. That is the corrupted activation file story in plain language. When the source points here, the remedy is not another key. It is a controlled reset of the software licensing state, a command that tells Windows to rearm its licensing machinery so the evidence can be rebuilt cleanly. The tool is Software Licensing Manager, spoken as SLMGR. The switch is -rearm. Open command prompt as an administrator. That elevation matters. Ordinary privileges are not enough to rewrite licensing state. You are asking the system to touch a protected subsystem. In that elevated window, run exactly slmgr space -rearm. Wait, a Windows script host confirmation should appear when the rearm request is accepted. Then restart the computer so the new licensing state is loaded from a cold start, not from half-remembered memory. What did you just do in story terms? You did not invent a new license out of thin air. You asked the operating system to clear a damaged trial and activation counter path and prepare to reestablish proof. It is the digital equivalent of wiping a smudged fingerprint card and taking a clean print. Still of the same person, if the person is who they claim to be. A reset can refresh the evidence. Here's the next hook, and it is a good one. What if the records are fine, the key is fine, and Windows still cannot complete the check? Because a service that needs to participate is locked out by policy. The investigation moves from files to permission. Who inside the operating system is allowed to ask the licensing questions at all? Every large building has service corridors. Windows is no different. Deep in the system, services run with carefully limited identities. One of those services is plug and play, the machinery that discovers hardware and keeps device identity coherent. Group policy can silence, constrain, or leave undefined how that service is allowed to run. And when the policy fabric is wrong, activation can fail in a way that looks nothing like a bad key and everything like a locked door. The source's third method is a policy investigation. Open run again, this time type rsop.msc, resultant set of policy, and press enter. You are not guessing at a single registry value yet. You are asking Windows to show the effective policy the machine is actually living under. Navigate with patience. Move through computer configuration, then Windows settings, then security settings, then system services. Find plug and play. The source's instruction is specific. Change the setting away from not defined. You are forcing an explicit policy state instead of an ambiguous inheritance that may be blocking the service path activation depends on. Apply the change, then open an elevated command environment and run gp update /force. That command shoves group policy to refresh now, rather than waiting for the next background cycle. Restart again. Cold boots matter when policy and services renegotiate who is allowed into which corridor. Stay with the metaphor. A reset of licensing files is like reprinting the ID card. Group policy is like rewriting the building's access list, so the guard who checks IDs is even allowed to stand at the door. If plug and play is misscoped, the machine may know its own story and still fail to tell it. And yet there is one more locked room. Sometimes the policy looks correct, the service is present, and the last failure is raw permission on a registry hive that the network service account must read. The system may know the answer and still be locked out of the room where the answer is stored. Registry Editor is not a toy. It is the hierarchical database where Windows stores configuration that services treat as law. Method 4 sends you into a precise address, HKey users, then the security identifier S1520. In plain speech, that hive is tied to the network service account, a built in identity many system components use when they need to act on the network's behalf without being a full administrator logged in at the keyboard. Open Registry Editor, navigate to HKey Users, then S1520. The source's instruction is not to delete the key, not to invent values, but to inspect and correct permissions. Add or verify that network service has the access it needs on that key. You are restoring a right of way, not rewriting the map of the city. Why would this matter to a not genuine watermark? Because activation is not a single dialogue, it is a conversation among components. Some of those components operate under network service. If that identity cannot read or write the licensing related state hung under its own hive, the conversation fails mid sentence. From the desktop, you still see only the public shame of the watermark. Underneath, a service was denied at the door. After the permission is corrected, restart once more. The pattern across the technical methods is deliberate. Change state, then reboot, so every dependent service reloads under the new rules instead of caching the old denial. Feel the ladder you have climbed. First, offer a valid identity with the official activator. Second, rearm damaged licensing evidence. Third, fix the policy that governs a critical service. Fourth, restore the registry permissions that let network service reach its own room. Each rung answers a narrower version of the same question. What exactly did Windows lose? Return to the opening image, a familiar desktop, a thin accusation in the corner. Features at risk, the fear that your machine has been judged counterfeit. What this knowledge makes possible is narrower and more powerful than a single guaranteed cure for every PC on Earth. It turns a vague moral panic, my Windows is not genuine, into a sequence of testable possibilities. You begin with the official activation path and a valid product key, because that is the relationship Windows was built to verify. If identity is not the break, you rearm the licensing evidence. If evidence is not the break, you inspect the policy that governs plug and play. If policy is not the break, you restore network services right to its registry hive. At each step, you change one variable, restart, and observe. That is diagnosis, not superstition. Trust in this story is not a feeling, it is a stack. Key, records, service policy, and permissions. When any layer fails, the public message collapses into the same watermark. The fix is to find which layer actually tore. And still the field keeps one honest question open, a question the troubleshooting page cannot fully close. When Windows loses trust in a machine, how can it distinguish a genuinely changed identity from damaged evidence of the same one? Hardware shifts, files rot, policies drift, permissions decay. From the outside, the symptom is identical. From the inside, the difference is everything. Until operating systems can narrate that distinction in human language, investigators, including you, will keep climbing this ladder. Identity first, then evidence, then who may ask, then who may enter the room. The watermark is loud, the method is quiet. Use the quiet one.